Hello everyone. In the continuation with respect to the application of the composite material, now we will discuss about the application of the cemented carbides. In this, the first what we discuss is with respect to the tungsten carbide ceramides. Normally, the tungsten carbide are used for the cutting tool applications. The most commonly used in the case of either it may be in the dies or maybe the drilling bits or other mining tools. Dies are manufactured by using the powder metallurgy techniques and where the material is very hard and it can take the very huge loads. The titanium carbide ceramides. Titanium carbide ceramides are the high temperature application such as the gas turbine nozzles, vanes or vane seatings, thermocouple protection tubes, torch tips, cutting tools for steels, etc. Chromium carbide ceramides are also having a high temperature application and also high hardness applications which is used in the case of the gauge blocks, wall liners, the spray nozzles and as well as the bearing seals rings. If I take an example of with respect to the CFRP applications, nowadays the modernized cars what we are getting it is most of the application is of the FRP by which automatically the weight reduction will take place and also we can achieve the strength as that of the normal sheet metal. Now, with respect to the aerospace application, most of the aircraft industries having a major application, either it may be with respect to the CFRP or hybrid or FRP or even the fiber glassed composites. Especially in the aerospace industries, all the three categories, either it may be the MMC, CMCs and PMCs are having a major applications. The composite materials for the wind turbine blades. The most common applications in the case of the renewable engineering is the wind turbine. In the case of the wind turbine, the blades length runs in terms of the meters. If these blades are manufactured or fabricated by using the metallic material, then the weight is another factor. To reduce the weight in these cases, the blades are fabricated by using the composite materials. Now, one or more carbide compounds are bonded in a metallic matrix material to form a very hard material, which is nothing but the MMCs. The common cemented carbides are based on the tungsten carbide, titanium carbide, and as well as the chromium carbide. Even the tantalum carbide is another composite which is having a less application than that of the tungsten carbide, titanium carbide and as well as the chromium carbide. The metallic binders are usually either it may be a cobalt or it may be a nickel. These having a major applications in the case of the MMCs. In the case of the medical field, a composite is a non-viable material used in the medical devices and intended to interact with the biological systems. Over the centuries, advancement the synthetic materials and as well as the surgical techniques and as well as sterilization methods have predominant use of the composite material in many ways. Medical practices today utilizes a large number of devices and even the implants are also fabricated by using the MMC methods. The composite is the form of sutures and even bones as well as the joint replacements, vascular grafts, heart valves, intraocular lenses, dental implants, pacemakers, biosensors, artificial hearts, etc. Widely used in the replaced and as well as the restored function of the disturbed or degenerated tissues of organ to improve the functions and to assist in the heal to correct the abnormalities and thus improves the quality of the life of the patients. Applications in sports field. The composite materials are also having an application in the sports industries, or it may be in the sports field, especially the rackets or even the bats which are fabricated by using these are having the major application in the case of the sports. The boards, the rackets, and even the badminton rackets, or even the softball bats or high skis, bows and arrows are fabricated by using the composite material technology. The other composites are having a long been used in the construction for the industrial support buildings, like long spans of the roof structures, tanks, bridges, components, and the complete bridge systems. With the composite exhibiting the excellent resistance to the marine environment, the marine field is also having a major application. With the help of the composite, we can make a lightweight doors, windows, furnitures, buildings, bridges, etc. for the domestic and as well as the construction applications. The composite materials are commonly classified into two distinct levels. The first level is classified usually made with respect to the mixture constituents. The first one, the major composite classes includes either it may be the organic matrix composites, metal matrix composites, ceramic matrix composites. The term organic matrix composite is generally assumed to include two classes of composites, namely the polymer matrix composites and the carbon matrix composites, commonly referred it as carbon-carbon composites. The second level of classification refers to the reinforcement forms of the fiber reinforced composites, the laminar composites and particulate composites. The fiber reinforced composites can be further divided into those containing a discontinuous or it may be a continuous fiber. Depending upon the type of the application, even the natural fibers or the artificial fibers can also be used in the case of the composite technology. Fiber reinforced composites. Fiber reinforced composites are the composites in which the fibers are reinforced as a supporting material in the composite materials. These composites are considered to be either it may be a discontinuous or it may be a continuous. If it's a discontinuous means normally the short fibers are used as a supporting material. If it's a continuous means a long fibers which runs in meters, that is used as a continuous fibers. These continuous fibers either it may be in the fibers or even it can also be rolled as a mats. On the other hand, when the length of the fiber is such that any further increase in length does not further increases the elastic modulus of the composites, the composite is considered to be a continuous fiber reinforced. The fibers are small in diameter. When they are pushed axially, they bend easily, although they have a very good tensile properties. These fibers must be supported to keep a individual fibers from bending and buckling. Laminar composites. Laminar composites are composed of a layers of material held together by a matrix. Sandwiched structures falls under the category the particulate composites. The particulate composites are the composites where the particles are distributed or embedded in the matrix body. The particles may be either it may be in the form of a flakes or it may be in the form of the powder form. Concrete and wood particles boards are examples of this category. The composites are further classified into a particle reinforced composites, fiber reinforced composites, and as well as the structural composites. In the case of the particle reinforced composites, the large particles are dispersion particles. In the case of the fiber reinforced composites, either it may be a continuous fiber or it may be a short fiber or a discontinuous fiber. Even this discontinuous fiber, either it may be a aligned or it may be a randomly oriented. Normally, the structural composites are the composites where the laminates or it may be a sandwiched panels. The polymer matrix composite. The polymer matrix composites are the composites where the polymer is used as a matrix material. The two main kinds of the polymers are the thermoset polymers and as well as the thermoplastic polymers. Thermoset have a qualities such as well bond three-dimensional molecular structure. After curing, they decompose instead of melting and hardening. Merely changing the basic composition of the resin is enough to alter the conditions suitably for curing and determining the other characteristics. They can be retained in particularly cured condition to over prolonged period of time and rendering the thermoplast very flexible. Thus, they are most suited as a matrix based for the advanced condition fiber reinforced composites. Thermosets finds a wide range of application in the chopped fiber composition form, particularly when a pre-mixed or a molding compound with a fiber of a specific quality and aspect ratios happens to be a starting material as an epoxy polymer and a phenolic formaldehyde resins. The classification, the thermoplastic and as well as the thermoset. In the case of the thermoplastic materials, polyethylene, polystyrene, polyamides, nylon, polypropylene are some of the matrix materials normally having a major application in the composite industries. In the case of the thermoset, epoxy material, phenol formaldehyde resins and as well as the polyesters are having a major application in the case of the composite material. The main difference between a thermoset and as well as a thermoplastic material, in the case of the thermoplastic material where the recycling is very easier, but in the case of the thermoset material, recycling is very difficult or it cannot be recycled at all. The metal matrix composites. The metal matrix composites are the composites where the metal itself is used as a matrix material, where a high strength, fracture toughness, the stiffness can be obtained than that of the normal metals. They can withstand a very high temperature and even in the corrosive environment also. Most of the metals and alloys could be used as a matrix and they can require a reinforcement material which needs to be stable over a range of temperatures and even a non-reactive too. However, the guiding aspect for the choice depends upon the matrix material and the light metal, like either it may be aluminum or copper, etc. The light metal forms of matrix for a temperature application and the reinforcement. In addition to the forementioned reasons, the characteristics can be obtained for a high moduli.